Hello guys, you're welcome back to our channel, the kool-ace Educational Media. Today we are going to be talking about longitudinal wave, especially sound wave. And there are specifically three questions we intend to answer at the end of today's class. And that is, what is sound wave and how can it be produced and propagated? Secondly, what are the categories of sound wave? And finally, what are the characteristics of sound wave? So quickly, what is sound wave? So we can define sound wave as a wave which moves through a medium which can produce sensation of hearing. So in other words, we can say that sound wave is produced by sources which vibrate. So when a vibrating object disturbs a medium, what happens is that waves are produced. And once the waves are produced, they travel outward from that particular source. So this wave motion that travel out of that source is called sound. So we can actually just conclude that sound is a product of vibration. Secondly, in your previous class, we talked about the work, energy, and power. And under energy, we did mention that sound is a form of energy. So it means that we can also talk about sound as a form of energy that is produced by vibrating bodies. This can be observed when we strike a tuning fork. Once you strike a tuning fork, what you see is that the prongs vibrate, and these vibrations give rise to the sound wave. So in summary, we can say that sound wave require a material medium for their propagation. And also you'd have to take note that the nature of the vibration and the mode of the transmission would determine the type of sound that can be detected. Now, having said that, how can sound wave be propagated in air? Now take a look at the drawing there. You will notice that sound wave can be propagated by the vibrations of the prongs of a tuning fork. Now, if you take a good look at that drawing, you would understand that when the vibrating prongs move to the right position, what happens is that it compresses the air molecules that are nearest to it. And this creates a disturbance that is transmitted from particle to particle through the air. So in this way, a pulse of compression moving outward from the prongs is produced. Now similarly, when the prongs move to the left position, what happens is that the pressure on the nearest layer of the air is reduced as a result of what we refer to as rarefaction. Rarefaction is actually air pressure that is below normal, right? So as a result of this movement, a series of alternate compressions and rarefactions, they travel out and propagate through the air. Also, I could describe an experiment to demonstrate that sound waves require a material medium for its transmission, because we know that sound cannot pass through a vacuum. So to achieve that, I'd need a bell jar, an electric bell, and a vacuum pump, amongst many others, as you can see from the drawing there. So what is the method? Now the apparatus is set up as you are seeing it in the drawing there. So when the bell is switched on and there is air in the jar, the result is that the bell is heard ringing. But as the air is pumped away using the vacuum pump, what happens is that the sound gradually dies away, but you will see the clapper of the bell is still striking the gong. So what is the result, or what will be the conclusion? The conclusion is that no sound is heard once a vacuum is created in the jar. But when air is allowed to return to the jar, the bell is heard again. Hence, we can say that sound wave cannot travel through a vacuum. Now, secondly, what are the categories of sound waves that we are going to be discussing today? There are basically three categories of sound waves that we are going to be looking at today. Number one is what we refer to as audible waves. Now, what is an audible wave? An audible wave are longitudinal waves that fall within the range of sensitivity of the human ear. Now, why we say they fall within the sensitivity of the human ear is because you can be able to hear these sound waves with the human ear. So, in other words, sound waves with frequency that are ranging from 20 hertz to 20 kilohertz are known as audible sounds. Now, this is so because the human ear is sensitive to every minute pressure difference in the air if they are in the audible frequency range. That is this range of 20 hertz to 20 kilohertz. But the challenge is that as we grow older and are exposed to sound for a longer period of time, our ears get damaged and the upper limit of audible frequencies would decrease. So for a normal middle-aged adult, the highest frequency which they can hear or hear clearly is 12 to 14 kilohertz. Now, secondly, we have another category of sound waves that we call the infrasonic waves. Now, infrasonic waves are longitudinal waves with frequencies that are below the audible range. That is, the range is less than 20 hertz. And some sources of these infrasonic waves in nature includes volcanoes, includes avalanches, earthquakes, and the likes. And then finally, we have the third category, which we refer to as the ultrasonic wave. The ultrasonic wave. These are longitudinal waves with frequencies that are above the audible range for humans. Right? This one, you see it in certain dogs, cats, bats, and some other animals. They hear sounds of this range. If I must have to be particular, bats, for instance, they use frequencies up to 120 kilohertz for their exploration or navigation. There are also some special kind of whistles that produce ultrasonic waves. So in summary, most ultrasonic waves, they have frequencies that are ranging from 20 kilohertz to 100 kilohertz. Now, these ultrasonic waves, they actually have some useful applications. For example, they can be used in ultrasound imaging. In ultrasound imaging, they are used for examining the liver, the fetus, and everything like that, and they are safer than X-rays. We also have what we call the ultrasound flow meter, which uses what we refer to as Doppler effect for measuring the speed of blood flow. You can also use ultrasound to remove delicate brain tumors in what we refer to as the use of Cavitron ultrasonic surgical aspirator. That is CUSA, Cavitron ultrasonic surgical aspirator. Even in industries, ultrasound and ultrasonic waves they have useful applications. For example, they are used in quality control of friction pads for automobiles and aircraft discs, as well as what we refer to as automatic rangefinders for cameras. So these are the basic categories of sound waves. And then finally, for this particular segment, the characteristics of sound waves. So there are three basic characteristics of sound waves, or what we call characteristics of musical notes. But it is important for us to know that every musical instrument produces a note. So the notes from different musical instruments are distinguished from each other by their pitch, by their loudness, and also by their quality. So we're going to take them one after the other. Number one, the pitch. So the question is, what is pitch? Now, the pitch is the term that is used to describe how high or how low a musical note is. The meaning of that is that a source which vibrates at a high frequency produces sound at high pitch. And also, a low pitch note is produced by a source of sound that vibrates at a low frequency. So that implies that the pitch of sound is dependent on its frequency. Now you look at the drawing there. The cat and a human being, the cat and a man, the production, the frequency of vibration of their sound is different. The frequency of vibration of the sound produced by the cat is higher compared to the frequency of vibration of the sound produced by the man. Remember, we had already established that wavelength and frequency are inversely proportional to each other. So you can see that the wavelength of the cat is less, which means it has high frequency, and the wavelength of the sound produced by the man is high, which means low frequency, and that is also referred to low pitch in that case of the man. Secondly, we have loudness. What is loudness? Loudness is a term that is used to describe the intensity or amount of energy that is transferred by a sound wave in a specific direction. So, the implication of that is that the loudness of a note depends on the amplitude of that sound wave. So, it means that a loud sound has a higher amplitude than a soft sound, and therefore it contains more energy. So if you take a look at the drawing there, you will notice that there's a big difference between a musical note of a loud sound and that of a soft sound. You can see that the amplitude is much for a large sound. But please take note that the loudness of a sound depends on a number of factors. I'll mention three for you now. Number one, the loudness of a sound depends on the total mass of air that is set into vibration. Now, how is that true? When a tuning fork is set into vibration and held near the ear, what happens is that a soft sound is heard. But if the tuning fork is pressed on the surface of a table, you would observe that a loud sound is being heard. Now, this is because the tuning fork forced the table surface to vibrate, and that vibration will in turn force the air that is close to it to vibrate. So the large mass of vibrating air will now produce the loud sound that is being heard. Now, number two, loudness of a sound depends on the strength of the initial vibration of the source of sound. And then number three, the loudness also depends on the distance of the source from the observer. So these are three key factors that the loudness of a sound depends on. Let me run it through again. The total mass of air that is set into vibration. Number two, the strength of the initial vibration of the source of sound. And then number three, the distance of the source from. Now, the third and final characteristics of musical notes is quality. Another name for quality is timbre, and it is the characteristic of a note which helps us to identify sound from different musical instruments which have the same pitch and loudness if played at the same time. So we can say that quality of a note depends on the harmonics, or what we refer to as the overtones. Now, by that, I mean that the same note sounds differently if played on a piano or on a guitar or on a violin. So the difference in the note produced by this musical instrument is due to the number and strength of the overtones that are combined or blended to form the note. So I'm going to be taking time to expatiate more on the overtones and harmonics in our next class. So I'm pretty much sure that you benefited from today's class. Now, I'd like you to stay tuned. There are so many things yet to do on the sound, and that will be coming up in our next episode. And in that episode, we are going to be looking at the transmission of sound through matter, solid, liquid, and gases, the velocity of sound, and the factors that affect the velocity of sound in air. We are also going to be looking at the properties of sound: reflection, refraction, diffraction, and interference. Remember that we already mentioned that polarization is not for sound waves, because polarization is only for transverse waves, and longitudinal waves cannot be plane polarized because they are already polarized. So also we are going to be differentiating between an echo and what we refer to as reverberation. And in that class also, we are going to be looking at the uses of echoes And then we are going to talk about resonance and forced vibration, and of course beats and beat frequency. So you can see we have a lineup of subtopics to come, so I'd like that you stay tuned. They are going to be coming in quick succession. Thank you for your time. I do appreciate. Remain blessed.